Okay, so in this particular segment, we're gonna go over the rules for assigning oxidation states. Rafi hasn't still joined us. So on simple ions, the oxidation state is equal to the charge on the ion. ठीक है? So copper जो है उसका charge जो होता है it's +2, even though it's a transition element, but copper can exist as copper +2 भी exist कर सकता है, it can also exist as copper +1. ठीक है? So it's for simple ions, it's just the charge on the ion. Okay, that is the oxidation state. Chlorine belongs to group 7, and that's why it has a charge of -1. So it will have an oxidation state of -1. अच्छा, in aluminium oxide, in Al2O3, in Al2O3, simple एक और भी हम एक trick कर सकते हैं, we can also do a trick that if you have like Al2O3 written like this, okay? So basically we have Al2, right? And O3. This is a simple trick. You just cross multiply, okay? So 2 will go here and जो 3 है, it will go here, right? So अब हमें पता है कि metals जो होते हैं they have a positive charge because they lose electrons, right? So aluminium का क्या हो जाएगा? So if we rewrite the oxidation states in aluminium oxide, so aluminium will be Al +3, okay, 3 इधर, and oxygen will be -2. ठीक है, okay, it's a non-metal. समझ आ गया? Did you get this?
जी।
Okay. In elements, the oxidation state is always 0. ठीक है, so जैसे मैंने आप लोगों को पहले बताया, you have done with this rule. So जैसे मैंने आप लोगों को पहले बताया कि elements in their free form, they always have an oxidation state of 0. ठीक है, so they have neither lost electrons or they have neither gained electrons. Their oxidation state is 0. The total oxidation states must always equal the overall charge on the species. ठीक है, so the total of all oxidation states must equal the overall charge on the species. So what is the what does this mean? So what this means is if you sum up the oxidation states, it should equal the charge on the species, right? We'll look over that example in the next page. The total of all oxidation states must always equal the overall. अच्छा, कर चुके हैं, ठीक है. In molecules and more complex ions, the more electronegative element is assumed to be the negative ion. What does electronegative mean? Any idea? What is electronegative? Hazan. Okay, so इलेक्ट्रोनेगेटिव जो होता है ना, इलेक्ट्रोनेगेटिव का मतलब होता है कि दैट पर्टिकुलर एलिमेंट हैज द एबिलिटी टू अट्रैक्ट मोर इलेक्ट्रॉन्स. सही है, सो इफ दैट एलिमेंट हैज मोर प्रोटॉन्स, that means it has more positive charge, right? So it will have a greater tendency to attract electrons. सही हो गया? If an element is bigger in size, so the distance from the nucleus will increase, and if an element is like this small, okay, so this is the nucleus, and the force of attraction between the nucleus and the electrons is very strong, right? But if an atom is like this small and the outermost shell is like really far apart, so the electrostatic force of attraction is really weak, and the electronegative, and that element is not that electronegative. It has a very weak tendency to attract the electrons, right? So In molecules and more complex ions, the more electronegative element is assumed to be the negative ion. Okay, so for example, if you talk about this methane, okay, in the methane example, so carbon is more electronegative as compared to hydrogen. Okay, hydrogen exists on the far left, carbon exists on the right side of the periodic table. And when you move from left to right on the periodic table, the electronegativity increases. Okay, so uh, that's why methane इसमें carbon has a charge of -4. ठीक है, even though it's not an ionic compound. Methane is not an ionic compound, it's a covalent compound. But in covalent compounds, we use this rule. The more electronegative element is assumed to be the negative one. And the hydrogen will automatically have a positive charge. Similarly, in carbon dioxide, carbon has a +4 charge and oxygen has a -2 charge. Even though they're both non-metallic elements, but oxygen is way more electronegative than carbon, and that's why it has a -2 charge. That's why we assign the -2 charge to the negative charge to oxygen. And water, once again, oxygen is more electronegative because it exists in group 2, and that is very much on the far left of the far right of the periodic table. So that's why it has a negative charge. Group 1 जो है, sorry, this is group 1. ठीक है, so group 1 is always +1 and group 2 is always +2, right? एक और भी रूल इसमें ऐड करते हैं, if you attend the previous class, जो transition metals होते हैं, they have a variable oxidation state. ठीक है, so for example copper, ठीक है, it can exist in +2 form as well, and can also exist in +1 form. सही है. Iron is also a transition metal. ठीक है, it can exist in +2 form and it can also exist in +3 form. ठीक है, these are the rules for assigning the oxidation states, right? Acha. Now let's look over some of the ions that you should know. ठीक है. Acha. Azlan and Maham, you should just memorize the charges on these ions. ठीक है, you just need to know the charges on these ions. But you just need to know them ताकि you can easily solve equations and when we go over electrolysis, so it's much easier for you guys to figure out. So you need to memorize some of these ions and their charges. So with the ammonium ion, which has a +1 charge, hydroxide ion, a -1 charge, nitrate ion has a -1, sulfate has -2. We have bicarbonate ion. This is not hydrogen carbonate. It's termed as bicarbonate. So bicarbonate ion has a charge of -1 again. Okay. This is the carbonate ion, which has a charge of -2. Is not very important. Phosphate ion once again has a charge of -3. So ये charges जो है ना, you should memorize by heart, right? अच्छा. So right here we have to calculate the oxidation state of the stated elements in each of the following species. Let's just do an exercise, and then we'll just end this lecture. So before we start this exercise, is everything clear regarding oxidation states, redox